So, yeah, it's been a real challenge. I've wanted a security system like this for many years, but this hill is basically you go down a foot under the dirt and you're into rock, and it's extremely hard to dig ditches, and there's no way to do a comprehensive video surveillance system without lots and lots of ditches. And at any rate, it's progressed nicely. I'm not naked in the woods anymore. I'm able to at least get a look, although I seldom look at it. There's no reason for me to look at it unless there's a problem. I ain't got time to sit here and monitor it all day. So we do have everything being recorded on this 6 hard drive apparatus over here. I don't know how it works. I'd have to call in somebody.
But if there's a problem, it'll be all documented.
Hopefully it may be just outside the reach of the camera. I tried to look at the limb that fell and killed their dog. I tried to look at that just to, I guess, pay respect or something, because I wasn't going to make her own dead.
Yeah.
But it was just far enough away from the camera and out of the central view of the camera enough that it was not very useful. At any rate, the most useful thing that I've had from it was I just scanned before I was going to bed recently, and I was able to look inside of their church, their whelping kennel, and see that a female that we had been long anticipating her next litter was in fact giving birth, but she wasn't like settled down. She was agitated and walking around. And I got there and she had 2 puppies kind of pushed off to the side, and she still darted back and forth in the brood area, and was able to get her to lay down, get the pup started nursing. Pups nursing contributes more positively to causing bitches to resume labor and maintain focus on doing their job. I guess Mother Nature thinks that if they're nursing, then there must not be any real threats in the environment, and it's not chaos. There's not a predator eating her babies as fast as she has them. So, we'd like to assist in seeing that natural, normal nursing goes on as soon as possible after the delivery, after labor initiates.
Well, good deal. Well, today we wanted to talk about outcrosses, new genes for the program, when and why you do that. So I'll go ahead and let you take it away on the when and the why and the reasons for it.
Thank you. Today is February the 6th, 2025. In case somebody in the future is looking at this and say, well, that's got to be back in the 50s, doesn't it? It's actually 2025, February the 6th. Hopefully you're here to learn rather than just simply to be entertained. I'm here to teach. Believe it or not, in my 47 years, I picked up some useful ideas as evidenced by our success rate. Every year older I get, the more I fear that my ability to share these ideas may be diminished. Hopefully I haven't reached that point yet, but I'm going to do my best today to share some ideas that I think many serious breeders will find to be useful and beneficial. One thing that I pointed out in the article that I wrote in a 2003 issue of the Journal magazine, not the Sporting Dog Journal, but a magazine called The Journal, that I published in 2003 and 2004, in an article in the second issue of the Journal called Physical Conditioning. I shared element that I employ that I have found to be very, very beneficial, and that is thinking in an evolutionary context. When you're trying to unravel some of the mysteries of what natural functioning is for a dog, um, it's very useful to look at predecessor species and populations and see what they do given similar environments, similar processes, what they do, and you can get lots of clues regarding what the natural process is. One moment.
Yeah.
Papers in the top drawer right there. So I call that TEC, T-E-C, thinking in an evolutionary context. I found it to be very, very useful in giving me order and direction in my thought. Usually when you see behaviors occurring in a species universally, it means that those behaviors and those tendencies and those processes have been well validated over tens of thousands of years, and that while they may not always be perfect, they will yield the predominant amount of truth. So one thing that I covered, one group of truths that I uncovered that people would normally argue about with every possible position having a proponent, was if you are conditioning a dog, let's say for a hog hunt, and you want to know, well, how much do I need to work this dog? When do I need to work him? At what intervals? And when do I need to feed him? How much rest does he need? So in order to answer those questions for my own purposes, and then ultimately to share with other dog men, I thought, well, what happens, for example, with wolves in the wild, or likewise with most predator animals? They don't do a lot of work just for aesthetic reasons. They don't move a pile of dirt because they think it might be nice to have it over there instead of over here. They work because they're hungry. So one can begin to reach conclusions from that. Don't work your dog when he's got a full belly. Initiate work-rest cycles so that the dog is empty when you work it. Well, what does it mean to have an empty dog? Well, the dog will have defecated. If you want to know exactly when and how that process begins and ends, put a little bit of corn in your dog's food, and then see whenever it comes out in the stool. That's usually about 22, 23 hours. I like that feeding cycle for a dog, but you could probably find the same thing in a wolf. Running around in a half-fed, half-hungry state all the time is not the ideal state in which to perform a physical task, because blood is diverted from the muscles to the intestines to continually assist in digestion. But at any rate, so you look at the natural cycle in wolves. They don't work till they're hungry. When they're hungry, they hunt for and pursue prey animals, and whenever the larger the prey animal, the more work that they have. So you might have foxes that are killing mice. They're doing a little bit of work, and they're doing it pretty much off and on all day long. That's a different kind of critter than the wolf. The wolf may be trying to drag down a deer. They have to run, who knows, 10 miles. So it's a prolonged, extended work effort. And so when do they, after the work, when do they eat? Do they wait till 3 hours? No. They did the work because they were hungry. and they dispatch the animal, and then immediately consume what they can of the different parts of the prey animal's body. Some will argue that they go to the stomach first to restore blood sugar because of pre-digested carbohydrates that exist in most prey animal stomach. Some people argue against that. I don't know if it really matters. It's not, the whole thing doesn't hinge on it one way or the other. But so here we're establishing the when to eat, what state of hunger should they be in whenever they work. The next part is the rest cycle. In the rest cycle, the size, the amount of work and the size of the prey animal are directly in proportion to the amount of rest that they can actually afford to enjoy. If you're killing a deer, they might be able to eat on that thing 2 or 3 days on the carcass, and so it starts to take shape in your mind that if it's a really hard exertion to make the kill, then there's usually a couple of days of rest that goes along with it before you have to repeat the cycle. So if they're killing a handful of rabbits during the course of the day, it can be a little different. But for the true hard, preparing for a truly hard work effort, you're usually counting on a couple of days in between work efforts. So this is just an example of one of the collection of truths that can be gleaned from looking at your animal's ancestors or even contemporaries in an evolutionary context, in a real world nature context. So makes you wonder, well, what else can we glean from? What other questions can we answer from looking at these animals? What do they do in an evolutionary context? Well, we'll get to some other applications in a moment. One of the reasons that I'm bringing all this stuff to bear and setting the stage for this episode is we have been doing a round of breedings that, for those of you who follow our pages religiously, you will readily see that the patterns of our breedings are markedly different from what we have done over recent decades. Almost all the breeding that I've done over the years has been geared towards maintaining families of dogs. There were already families of dogs that had tested themselves or had come to be understood as being among the elite. They accomplished some aspect, at least one aspect of the breed standard better than any other bloodline. The lines are not always surgically clear, but I will identify some of the families and you recognize them as being components of our overall breeding operation. The Frisco Chinaman dogs, great overall dogs, a degree of success that is second to none, but they are largely from the Eli dog, so I could subsume them under the Eli category. So we have recognized the physical athletic excellence of the Eli dogs and realize that they are a component, a huge component of the Frisco Chinaman dogs. And in order to really capture what that's all about, we have to have the best examples that exist in the world of those bloodlines. So that's one component of their overall program here. Same is true of the Bolio dogs. Bolio dogs, smartest dogs in the history of pit bulls, and maybe the smartest dogs that ever lived. And essentially, the Frisco dogs are a combination of Eli dogs and the Bolio dogs. alligator dogs. The only way that I've owned and utilized alligator dogs is in combination with Eli dogs, in particular Chinaman or Spike dogs. And they are just fast-paced, hard-working, game, just remarkable animals in that combination. Red boy dogs, the same. They are they're excellent in all aspects of the breed standard, but they are known worldwide for their heart and courage. So what we have done for the most part up to this point is we've done a lot of line breeding and quite a bit of inbreeding in order to maintain the essence of these already proven families of dogs. So that's the rationale for all the close breedings, to reduce the variability. The Eli dogs in particular, they gain excellence through inbreeding because many of the desirable athletic traits in that family are controlled by recessive genes. So
Sorry to interrupt. You said inbreeding is to reduce variability. Why do you want to reduce variability?
Well, we don't want to call this the Noah's Ark of breeding program. Noah's Ark had two of every kind. Whenever you produce a litter, knowing that everybody wants the same outcome, they want a powerful, athletic, intelligent, natural cardio beast of a dog, and you want to be able to have uniformity in producing that. You don't have two that meet the criteria, two that are often left field somewhere being whatever else they could be, golden doodles. You got to have uniformity. If you look at how all of the breeds, virtually all the breeds that we came into our lives knowing what a beagle looks like, and they uniformly look like a certain thing. And the same is true of a poodle, and so on and so forth. There is uniformity. You've not really established the most perfect form of a breed of dog until you've met all of the breed standard criteria and you've done it uniformly, so that you uniformly meet those criteria. You don't just kind of have a couple from the litter that make it and a couple that don't. So you've got to reduce variability, and the close breeding does that. And it's a great assist for the breeder as well. My apologies. Probably one of you guys that's up there watching this now will remember calling me.
It was me. I was the one that called and interrupted the show.
Yeah. So we're trying to reduce variability. It makes breeding, it makes the challenges of breeding for the breeder much less, in that you want to get as a breeder, you want to get a grip on the rules that govern the breeding of each family of dogs. Every time you add an outcross to a known commodity family of dogs, so I've got a El Negro, very close bred El Negro female, and I know how to breed her because I've bred all of her brothers, sisters, cousins, and ancestors. But then I cross her to Red Boy, and then I take dogs from that litter. I really don't know whether the dogs from that litter are going to follow the breeding rules for Red Boy dogs or Eli dogs, or have a new set of rules. So in order to simplify things, it's very useful to reduce the variability through close breeding.
And that reduction of variability gives you higher percentage of great dogs that are reliably predictable.
Yeah.
Or gives you a foundation.
It just reduces variability.
Okay. Yeah.
It's internal reliability.
So then what are the pluses? What are the pluses and minuses of when you decide to outcross?
Well, that gets us to a field of study that some of our listeners may be somewhat familiar with, having gone through high school biology. Uh, one basic rule is that a closed breeding population will at some point only run out of all new possibilities. There won't be new combinations to ferret out and display into the phenotype. So that you have a new great characteristic that can be worked back into the entire population. So with a closed breeding group, you run that risk. You will reach that point if you stay closed. What happens in nature is populations, they expand and they contract due to going in wrong directions with new characteristics of the phenotype. If all deer were suddenly white, then population probably go down pretty quick because it's about 10 times easier to spot by a hunter or by a predator. That's just an example of how it could go wrong. But in general, Mother Nature will experiment with when populations are high at a high level, and local pockets of animals are the areas between these local pockets are being filled in by the elevated number of animals. You will have the phenotypes decidedly preferring the expression of dominant genes. Let me back up and talk a little bit about dominant recessive. Dominant genes, as the name says, whenever they're paired with recessive genes, they prevail. They are expressed in the phenotype. People with brown eyes, brown is dominant over blue. Each person or each animal is carrying two genes for each characteristic that will be displayed in the phenotype. The phenotype is, I should say, the actual physical manifestation of the genetics that both parents present into the newborn animal. So the animal gets genes from both parents. If there's a dominant gene present, it will dominate over any combination of recessives. If you have a dominant and recessive in one parent and two recessives in the other parent, the dominant gene will, whenever it is brought forward, will dominate and it'll make brown-eyed offspring over any other combination. But you look at all the permutations, and there is a little matrix that you could do called a Punnett square. Feel free to Google that. That will show that the proportion of characteristics that are manifest in the phenotype from dominant genes is 75% of all possible outcomes. And that leaves 25% of the characteristics that are expressed in the phenotype coming from recessives. So you can see in a far-reaching, expansive population, animals, people will say, wow, there's a lot of deer this year. There's jackrabbits everywhere. How many squirrels can there be? There's one on every limb and every tree. It's during those times that the species involved can gamble on the expression of new dominant gene combinations, could gamble on those working. In most cases, they don't. They're not retained through natural selection in the populations. But the ones that are retained, that do prove to be useful to the species in survival and flourishing, those can be invaluable. They can totally reshape the destiny of a species of animal. So what we're defining here is the conditions under which Mother Nature would use dominant genes, and the circumstances under which she would use dominant genes to bring forth new genetic material, new genetic combinations in high population times, so that if the combinations don't work, we're not threatening the very existence of the species. So, but then what happens whenever either the environment changes or the new genetic combinations prove to be worthless or even harmful? Well, then the population dies off, and as it reduces the expansiveness of the breeding range. You end up with local pockets of individuals from that species that over generations breed within themselves, and they become more and more genetically similar. So you have more and more recessives pairing up, and essentially it's a reset. I like to think of it as a reset. Those recessives are lurking back there in case of all the new possible ways of putting genetics together that's afforded during the high population times. There's always this second option, plan B, you might say, that the species can invoke, and it does so not by thinking it through, but these are tens of thousands of years of trial and error and survival of the fittest have invoked these possibilities to work diligently to allow every life form to, on the one hand, try to improve, but on the other hand, survive if a wrong move is made. So you get these pockets of animals that only do breeding locally, and then they start relying on, they're subject to the pressures of bringing the recessive genetics into the phenotype to try to restore something that has worked in the past. And so try to learn from that. And I would invite our listeners to ponder these scenarios and think, well, how does that relate to our highly organized attempts to manipulate genetics within our breed of dogs? How can I use that to make me a better breeder, in short? So we've reached that point, getting back to